Okay, this is Algebra 1, test, study guide for test 7. This is part 2. A mistake was pointed out from the end of part 1, everybody, on number 7. When you plug the number back in, we got to y equals -8, which was correct. But when I plugged it back in, I plugged it into the first equation. But notice on my first equation, I plugged it in as positive 12, or I used it as positive 12. That's actually incorrect. That's one of the dangers of having multiple copies of equations. Make sure you don't make that mistake. Make sure you check it twice when you plug it back in. 3 times -8 is going to be -24. All of the work is still going to wind up being the same, except we're going to be dealing with a different number when it comes to the other side. When we add 24 to both sides, we're going to get 6x equals 12 now instead of we got 36 a minute ago. And when you divide by 6 on both sides, we get x's new value, which is 2. So we have to correct that x's value from being 6. It's not 6 anymore. It's 2, -8. Number 8 says 5x plus 3y equals -17. 2x minus 3y equals -11. X is a stacked, y is a stacked, constants are stacked. And you have opposites already. So this one's set up real nice and neat for combination. 5x and 2x is 7x. 3y and -3y is no more y's. They're gone. -17 and -11 is -28. So it says 7x equals -28. Divide by 7. A negative divided by a positive is going to be a negative, and 28 divided by 7 is 4. So x's value is -4. Plug that back into one of the other equations. Now, the second equation looks like it might be a little bit easier to work. So 2 times x is 2 times -4. Remember, unless one looks the same, just use the top one. I just think it's easier with that bottom one. Minus 3y equals -11. Again, make sure when you're bringing that one out that you're not leaving anything off or any negatives or anything like that. 2 times -4 is -8. Minus 3y equals -11. Add 8 to both sides. -11 plus 8 plus 8. -3y is going to be -3. Divide by -3 on both sides, and a negative divided by negative we know is a positive 1. So you have an x and a y value. Again, x comma y, -4, 1 is the solution to that system. Okay, your picture come out a whole lot better looking than this one, but we could still see what the line does. Um, Looks like it's at 1, 2, 3, 4, 5. This is crossing through at 5. So the B value is going to be 5. Then you need to pick another point it's going through. You could have picked the one right. You could have picked this one. Either one of them would work. But it's going down according to the ones I'm using. 1, 2. Down 2 is -2. And to the right, 1, 2 is +2. So down 2 and over 2, your m value is going to be -1. So since you have an m and a b value, you write your equation, you write your inequality just like an equation. Y equals mx plus b. Y equals mx plus b. Plug your m value in, which is -1 or -x, and your b value, which is 5 plus or +5. So if it were just an equation, we would be done right there. Y equals Okay, so we have, if this were just an equation, it'd be y equals -x plus 5, but this is not just an equation, it's an inequality. It's an equation that it's a solid line, so we know it's going to be or equal to whatever it is, but it's also shading towards 0, 0. It's shading towards 0, 0. So if you want to make a statement that when you plug in 0, 0, since we're shading towards it, you're going to want a true statement. So if we plug in 0 for y is something, it's either going to be less than or greater than. Plugging in 0 here, -1 times 0 is 0 plus 5. So 0 is something 5. You want to make something that's a true statement there, since we're going towards 0, 0. 0 is less than 5. And since we know it's a solid line, Again, I know your picture's small, but it looks better than the one that's up here. It's a solid line. We're going to make it or equal to. So all you have to do, change about the equation is instead of it being equal, you change it to less than or equal to. So to make that look a little bit better, y is less than or equal to negative x, because there's no reason to write -1 plus -1x, negative x plus 5. This is your equation to represent what's going on with that. Number 10 is slightly easier, but my picture is even worse for this one probably, because it is a horizontal line. So we know we're only going to deal with one variable with this one. Again, we got a solid line, and it's showing everything above that. That's on the y-axis, so the y value is at -2. So if it were just an equation, it would say y equals -2. We know that that's not true. It's not just an equation. It's shading it. So it has to be a greater than or less than symbol with or equal to attached to it. So we know since it's shading all the numbers above -2, we know it's going to be y is greater than or equal to -2. If that doesn't work for you, again, you can say, well, what about if I plug in 0, 0? I want a true statement since that's the way I'm shaded. 0 is something -2. And again, and that something is to make a true statement greater than or equal to -2. Number 11 says solve the system of linear inequalities by graphing. So y is less than or equal to x plus 4, and then we have an inequality that is not as easy to graph right away. We have to move it. So this first one is easy to graph. It's mx plus b. Most of us can look at that and graph the equation part of it relatively easy. We know to begin at 1, 2, 3, 4 is where our b value tells us to begin. And we know our m value is 1, even though the 1's not shown, which tells us to go up 1 and over 1. Remember, all slopes or all m values are fractions. So you have to create a fraction by making it up 1 and over 1. Now this is or equal to. So here's the first difference if it's an equation or an inequality. First difference is a solid or a dashed line. Since it says or equal to, we know we're making a solid line. Then we have to shade one side or the other. It's not going through 0, 0. So if we plug in 0 here, is less than or equal to, plug in 0 for x, 0 plus 4. We want to see if that's a true statement. 0 is less than or equal to, not plus 4, 0 is less than or equal to positive 4. That is a true statement. Since it is true, we know we'll shade everything this direction. And again, look how neat I'm trying to be with my shading to where we don't have any mess. We have to change the second equation. We don't have to do a lot of changing to it. But in order to get it to where we can graph it, we have to make it say y equals mx plus b. We have to move 2x over to the right side by subtracting 2x. When I do that, I have y on the left by itself. I have -2x on the right. And I have -4. There's no reason to reverse the symbol because all we did was subtract 2x. So it says y is less than or equal to -2x minus 4. Again, just graphing it like an equation, you'd begin at -4, 3, 4. We're going to have to go down 2 more, so I'm going to go 2 more. But at -4 is where your first point would be. Your slope of that one, just like the other one that had 1, but this one's -2, we got to put it over 1. So go down 2 and to the right 1. So there would be your second point. Again, this is an inequality, so we have to determine solid or dashed line. It says or equal to. Remember, all we're looking at is this part right here. Does it say or equal to or not? It does. So it's going to be a solid line through those 2 points. And then we have to determine which way to shade it. It doesn't pass through 0, 0. So let's see if we have a true statement with 0, 0 or not. 0 is less than or equal to -2. Anything times 0 is 0. That's why we use it. 0, not negative, positive 4. I'll keep wanting to write that. It's -4. So 0 is less than or equal to -4. That is the question you have to determine if it's true or false. That is a false statement. So we don't shade towards 0, 0 there. We shade away from 0, 0 there. So if you look at your graph, this is where the overlapping area happens, this part down here. So this is the only area here and everything continuing in those two lines. That's the only area that'll make both the blue and the red correct. We're doing the same thing with number 12, but both of these are in nice, neat forms that we can graph quickly. We don't even have to move any of them. The first one, y is less than or equal to negative x minus 1. Begin at minus 1. You're going to have to go down 1 and to the right 1 more. So that's where you begin. Slope says negative 1, so go down 1 and to the right 1 more. It says or equal to again, so it'll be a solid line through those two. And then we got a shade, 0, 0. 0 is less than or equal to negative 0 is still 0 minus 1. 0 is less than or equal to negative 1. Not true. So you shade away from 0, 0 for that. The other one, y is greater than or equal to 2x plus 4. You begin at plus 4. So 1, 2, 3, 4 is where you begin. It says 2x. Remember, that's over 1. So go up 2 more and to the right 1 for your second point. Again, it says or equal to. So draw a solid line through those 2 points. And we're going to have to shade either towards 0, 0 or away from it. 0 is greater than or equal to 2 times 0. Anything times 0 is 0 plus 4. 0 is greater than or equal to 4. That is not a true statement again. So we're going to shade away. Here's 0, 0 here. We're going to shade away from it, which means we're shading there. So this is the area here where the blue and the red are overlapping. That's where they're going to share. That's the only area where it'll make both of them correct. That's the solution in that region there. Number 13 says solve the following systems of equations by graphing. Now, we can graph both of these equations, but we know even if we do it perfectly that there's some room for error when we solve by graphing. But that's the first way we learned how to do it. So this first equation, in order to graph it, we can actually graph it by using the x and y intercepts. So if I want the x-intercept, I know I plug in 0 for y. Negative 4x plus 3 times 0, that's going to eliminate that part right there, equals negative 12. Negative 4x equals negative 12, which is x equals positive 3. So the x-intercept for that one is 3. The y-intercept is when I plug in 0 for x. So negative 4 times 0 plus 3y equals negative 12. Again, that part eliminates. 3y equals negative 12. Divide by 3, y equals negative 4. So if I graph this equation, those are the two intercepts for that equation. Again, most people don't do this way, but it works just as easy to do it this way. The x-intercept would be at positive 1, 2, 3 is where it would cross through, and the y-intercept would be at negative 1, 2, 3, 4 is where it would cross through. So that line right there is going to cross through those 2 points, and I'll draw those two. I'll draw that line in a minute where I see where the other line is going to cross through. The other equation, negative 2x plus 3y equals negative 18, is also one that is will work well using intercepts. Negative 2x, if I want the y-intercept or the x-intercept, I plug in 0 for y. Plus 3 times 0 is going to eliminate that, equals negative 18. This eliminates. So negative 2x equals negative 18. When you divide by negative 2 on both sides, x equals 9. So that's at x's value is 3 a second ago. 4, 5, 6, 7, 8, 9 is where that one's going to cross through. You can do the same thing with your y-intercept. Negative 2 times 0 in place of x plus 3y equals negative 18. That part eliminates. 3y equals negative 18. Divide by 3, y equals negative 6. So we have negative 4 already. Negative 5. Negative 6 is where they're going to cross. And it looks like it's going to cross, they're going to cross in this area here somewhere. And again, this is the part where we don't like to use this because you still have to make an estimate with this. But they're going to cross somewheres in this region here. But since it tells us to solve by graphing, this is how we would do it. This is the point that we would have to make an estimate of what that point is. Okay, so that's solving it by graphing. You'd have to estimate what that is, and graphing paper will help tremendously with this. Now, we've learned 2 different methods since this way. We've learned 2 different methods, and this is actually set up nice and neat for us to where we can use the elimination method. Since all your x's are stacked, all your y's are stacked, and your constants are stacked, all you have to do is create opposites out of negative 4x and positive 4x, or out of 3y and negative 3y will be even easier. Multiply this equation by negative 1. Negative 1 times negative 4x is positive 4x. Negative 1 times positive 3 is negative 3y. And negative 1 times negative 12 is positive 12. Now you have equations that have opposites that are stacked. Negative 2x and positive 4x is going to be 2x. 3y and negative 3y is eliminated, and negative 18 and positive 12 is negative 6. So when you get x by itself, you divide by 2, and x is negative 3. So that's the point at negative 1, 2, 3 is where it'll cross. In order to find what the y is, you plug that back into one of the equations at the beginning. So the second equation looks like it might be slightly easier. Negative 2 times x is negative 2 times negative 3 plus 3y equals negative 18. Negative times a negative we know is a positive 6 plus 3y is equal to negative 18. When you subtract 6 on both sides, you get 3y equals negative 24. When you divide by 3 on both sides, y equals negative 8. So x comma y, this is actually happening at negative 8. X comma y is negative 3, negative 8. The algebra eliminates the guesswork from it, because even if you do it perfectly, even if you do it on a sheet of graph paper and it's perfect, there's always going to be that little bit of estimation of negative 3, negative 8. Solve this system using substitution. With substitution, it helps if you just write them side by side. Y equals 4x plus 8 and y equals 2x plus 10. This expression represents what y is because it says y equals that. So that means in place of y, we can plug in 4x plus 8 equals 2x plus 10. Subtract 2x on both sides since it's smaller. And 4x minus 2x is 2x. You still have plus 8. You still have equals 10. Subtract 8 on both sides since you brought your x's to the left. 2x equals 2. Divide by 2 on both sides. And x equals 1. So x's value is 1. Take that value 1 and sub it back in place of x. Y equals 4 times 1 plus 8. We know 4 times 1 is going to be 4. Y equals 4 plus 8. Y's value is 12. Again, x comma y, 1, 12. That is the point where the two equations will cross. That's the only point that's a solution to both equations, which makes it a solution to the system. Same thing for number 15. They're set up nice and neat for substitution. You write them next to each other is the first part that makes it easier. Y equals 3x minus 2. Y equals 2x minus 8. Here's your value for y. Plug it in right there. 3x minus 2 equals 2x minus 8. Subtract 2x on both sides. Leaves you with 1x here. Minus 2 equals negative 8. Add 2 to both sides. X equals negative 6. There's your value for x. Plug that back in place of x here. Y equals 3 times negative 6 now minus 2. Y equals negative 18 minus 2. Y is negative 20. X comma y, negative 6, negative 20. Again, the same thing. Y equals x plus 6. Y equals negative 2x minus 3. In place of y, we can substitute that in. So x plus 6 equals negative 2x minus 3. Add 2x to both sides. 3x equals, subtract 6 on both sides, negative 9. Divide by 3 on both sides. X equals negative 3. There's your x value. Plug that back into one of the equations at the beginning. Y equals negative 3 is now a value for x plus 6. Y equals negative 3 plus 6 is 3. X comma y, negative 3, 3 is the solution. Number 17, you have smaller values. This is a smaller expression, 4x. So we'll plug that one in place of y. So 4x equals 2x plus 6. Subtract 2x on both sides. It leaves you with 2x on the left equals 6. Divide by 2 on both sides. X equals 3. Plug that back into the easier of the two equations. Again, y equals 4x is the easier one. Y equals 4 times x is now 3. Y is 12. X comma y, 3, 12 is the solution. Number 18 tells you just simply to graph the inequality. We know y equals mx plus b tells us to begin at 1, 2, 3, 4, 5. There's your first point. We know the slope is negative 3. We got to make it over 1 because slopes are always fractions. So negative 1, 2, 3, and to the right 1 time will be our second point. If it were an equation, we'd draw a line through it, we'd be done. It's not. It's an inequality. We have to determine solid line or dashed line. That doesn't say or equal to. Since it does not say or equal to, we need to make it a dashed line through those 2 points. That's the first difference. The second difference is we're going to shade one of those half planes, either everything towards 0, 0, or everything away from it. Again, it doesn't pass through 0, 0. That's a good thing. So when we plug it in, we want to see if it's true or not. 0 is greater than, when you plug in 0 there, negative 3 times 0 or anything times 0 is 0 plus 5. 0 is greater than 5. That is not a true statement. 0 is not greater than 5. So to shade towards 0, 0 would be wrong, which means we have to shade everything away from 0, 0. Number 19 says write a compound inequality that represents each solution and graph your solution. We're going to graph it on a number line since all we're dealing with is one variable right here. All real numbers at least negative 5. So think about what's going on. At least negative 5. So x and negative 5, we want to put something right there. At least negative 5 means negative 5 or bigger. So x has to be greater than or equal to negative 5. The other part says at most 8. So x and 8, again, we're going to put something right there. At most 8 means that 8 has to be the bigger number right there because it can't be that big. So less than or equal to. It says to write it as a compound inequality, so we want to put these two together. Remember, this says this is your key right here from several weeks ago, and right here. It's an and inequality. That means x is going to be in the middle, negative 5 is going to be first, and 8 is going to be after the x. This is the one you want to look at since it's written in the same order. X is less than or equal to 8. Just put your symbol the same and make this other one match the same direction. Here is your compound inequality. Negative 5 is less than or equal to x, which is less than 8. Then it tells you to graph your solution. You only have to graph the numbers negative 5 and 8. This, and then graph them using this line here. X is less than or equal to 8, which means less than or equal to means color it in and go that direction. And x is greater than or equal to negative 5. Again, color it in, going that direction. There is your graph to go with. Number 20 says write the compound inequality that this represents. This is not showing any overlap, so this is going to be an or inequality. So do this one first. X is something negative 1. You know it's showing numbers that are less than, and the arrow's also pointing this way. So make your mouth of your big mouth or your inequality point that way. So x is less than negative 1, and then we'll look at this side over here. X is something 4. The arrow's pointing this way, so make the mouth point that way. But the difference between this one and the other one is this bubble is colored in unlike the first one. So this one's going to be or equal to. There is no overlap here, so this compound inequality is going to say x is less than negative 1 or x is greater than or equal to 4. 21 says solve this equation. 3x is smaller than 4x, so bring 3x over by subtracting it. 4x minus 3x is 1x plus 3 equals 8. Subtract 8 on both sides. I'm sorry, 3 on both sides. and you get x equals 5 is the solution. 22 says find the slope. M equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1, or y sub 2 minus y sub 1, 3 minus 6, over x sub 2 minus x sub 1, 7 minus 5. 3 minus 6 is negative 3. 7 minus 5 is 2. Your slope is simplified there at negative 3, 2. 23 says write the slope and the y-intercept. This is nice and neat in y equals mx plus b form. So your slope is your m value 1/5, and your y-intercept is your b value 7. 24 says write this one in slope and y. You're given a slope and a y-intercept, write the equation. So y equals mx plus b. M is negative 1. So in place of m, we're going to put negative 1, plus b is 6, positive 6. So y equals negative x plus 6, mx plus b. And 25 says write an equation that's parallel that passes through the given point. If it's parallel, it has the exact same m value. So the m value is going to be 3/4. It passes through the point negative 4, negative 17. So you're given a slope and a point. So we're going to use point slope form. Y minus y sub 1 is equal to m times x minus x sub 1. So y minus y sub 1 equals m times x minus x sub 1. We're going to plug those values in. In place of m, we're going to plug in 3/4. In place of the x sub 1 and y sub 1, we're going to plug these in, but we're going to plug in the opposite of whatever they say. Remember, that's the key since it says minus, the opposite. Y minus y sub 1, your y sub 1 value is negative 17. So in place here, we're plugging in positive 17. X minus x sub 1, your x sub 1 value is negative 4. So in place there, we're plugging in positive 4. And here's your equation. Y plus 17 equals 3/4 times x plus 4.